Okay, in this video we're going to look at graphing two more graphs in polar coordinates, functions. That's a little bit more complicated. The polar coordinate system I have there, that's from the OpenStax Calculus Volume 2. I think it's around page 645 is where that graph appears. So here we're going to look at graphing r equals 4 cosine of 3 theta. Now, I want to make it easy to graph, so I want my arguments, the 3 theta, I want that to be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are the nice, easy values to get off of your unit circle for the cosine and the sine. So 0, pi over 2, pi, 3 pi over 2, 2 pi. So what we need to do is to solve for theta is divide by 3. So 0 divided by 3 is 0. Pi over 2 divided by 3 is pi over 6. Pi divided by 3. 3 pi over 2 divided by 3 is pi over 2, and then 2 pi divided by 3. So we'll make our little chart, theta and 4 cosine of 3 theta. So first we'll start off with 0. Cosine of 0 is 1 times 4 is 4. Okay, when you plug in pi over 6, you're going to get 4 cosine of pi over 2. Cosine of pi over 2 is 0. Okay, and then we'll plug in pi over 3. So 3 times pi over 3 is pi. Cosine of pi is negative 1 times 4 is negative 4. And then pi over 2, that'd give us the cosine of 3 pi over 2, which is 0. And then one more, cosine of 2 pi over 3. Well, 3 times 2 pi over 3 would be cosine of 2 pi, which is 1 times 4 is 4. Okay. Alright, so for our graph in the xy plane, we're going to start off at a maximum at 4, and that's going to happen at 0 radians. So that gives us the point 4, 0. So we'll label our rings on the polar coordinate system, and we'll start off at 4, 0. Then at pi over 6, we're back to 0. Okay. And we can go ahead and trace the radial line pi over 6, which will connect to 7 pi over 6, and that can kind of help guide your graph there. Okay. And now we're going to continue our graph. So at pi over 3, we're now at negative 4. And then at pi over 2, we're back to 0. So we can use the radial lines pi over 2 and pi over 6 to kind of help guide this. We achieve a maximum, well actually it's a minimum, at pi over 3. And we're going to go the opposite direction of pi over 3. So go the opposite direction of pi over 3. Oops, wrong thing here. So go the opposite. We should be on 4 pi over 3. And we're going to go 4 units along 4 pi over 3. Okay. And we'll go ahead and sketch another part of the graph. There we are. Okay. And we actually do have an induced order, so let's go ahead and put that in. Okay, let's keep going. 2 pi over 3. We're back to our maximum at 4. So at 2 pi over 3, we're going to be at 4. And we could actually continue. We are increasing by pi over 6. So 2 pi over 3 is 4 pi over 6 plus pi over 6 would be 5 pi over 6. And we can go back to 0. Okay. And so we would have this last portion of the graph there. Okay. And we could draw in the orientation. Now, let's go ahead and back it up negative pi over 6. And that'll complete the last petal there. Okay. And so this is called a Rose-Petal or rose curve. My wife likes to call it a daisy curve or daisy petal because it looks more like a daisy, especially if you have higher arguments or larger arguments like a 10 theta or a 4 theta or something like that. It'll look more like a daisy, I suppose. Okay, so this is a rose curve, and it has 3 petals. Now, this one's a little tricky to convert into rectangular form. We're going to use the trig identity, cosine of A plus B is equal to cosine A, cosine B, minus sine A times sine B. And then we're also going to use the identity sine of 2A is equal to 2 sine A cosine A. So this one's going to take a little bit of work. So R is equal to 4 cosine of 3 theta, which we'll write as 2 theta plus theta. And using the above identity, the cosine of A plus B, it's going to be 4 cosine 2 theta, cosine 2 theta, cosine theta, minus the sine of 2 theta, sine of theta, okay, which is equal to 4. And then we're going to leave that cosine of theta there, and we're going to apply the identity cosine A plus B again to get cosine of theta, minus sine of theta, sine of theta, and that's using the top identity. The sine of 2 theta will be 2 sine theta cosine theta, and that's using the sine of 2A identity, and then times sine of theta. Okay, so R is equal to 4 cosine cubed theta minus cosine theta sine squared theta minus 2 sine squared theta cosine theta. Okay, so we got a cosine cubed, we got a cosine times a sine squared times a cosine. So there's like 3 factors in each one. We want to make them r sine and r cosine because r sine is y and r cosine is x. And because we have 3 factors, we're going to multiply by r cubed. So r times r cubed is r to the 4th. 4 r cubed cosine cubed theta minus, then we'll split up the factor of r cubed as an r and an r squared. And we'll split up that factor of r cubed as an r squared and an r. Okay, so r to the 4th, r squared is x squared plus y squared, so r to the 4th is r squared squared, so that'd be x squared plus y squared squared, equals 4. R cubed cosine cubed would be x cubed, minus r cosine is x, r squared, sine squared is y squared, minus 2 r squared sine squared. I switched the order, sorry. R cosine is x, and then r squared sine squared would be y squared. Okay. And we do have like terms. I suppose we could combine the xy squared and the minus 2xy squared, but we'll leave it there. So we're just about out of room. And this is called a Rose-Petal, and that's what we call this. So Rose-Petals. If your b is even and r equals a cosine of b theta, then the number of petals you're going to have, and either r equals a cosine b theta or r equals a sine b theta, is going to be double that. Okay, so for example, if you have a cosine of 4 theta, you're going to have 8 petals. If b is odd, r equals a cosine b theta, r equals a sine b theta are both Rose-Petals, and we actually did an odd number in the previous example, and that was 3, and we had exactly 3 petals. So if the b is odd, you're going to have exactly that many petals. Okay, all right, we got one more example to look at here. Okay, so last example on this video, we're going to look at r squared is equal to 4 sine of 2 theta. We don't want to have r squared being equal to any negative numbers. We don't want any complex stuff. So we're going to go ahead and take the square root. So r is equal to 2 square roots of sine of 2 theta. Okay, and kind of like what we did with the 3 theta, we want 2 theta to be equal to the nice values on the unit circle, 0, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to divide each one of those by 2. So we get 0, pi over 4, pi over 2, 3 pi over 4, and pi. So we're going to set up our table here. So 0, the sine of 0 is 0. Okay, we'll plug in pi over 4, that becomes the sine of pi over 2, which is 1. Square root of 1 is 1, times 2 is 2. Okay, plug in pi over 2 times 2 is pi, sine of pi of 0. 3 pi over 4 times 2 is 3 pi over 2. Sine of 3 pi over 2 is negative 1. And square root of negative 1 is going to be undefined, so we're not going to include that. And lastly, we'll do pi. So sine of 2 pi is 0, so that gives us a 0. All right, so maximum of 2. So I'm going to label, I'm going to skip, so this will be a half, 1, 1.5, and 2, just so it's a little bit easier to see. Okay, so we're going to start out at 0. At pi over 2, we're going to achieve our maximum. I'm sorry, not pi over 2. Pi over 4, we're going to achieve a maximum. And then once we get to pi over 2, we're going to be back at 0 again. Okay, so we're going to come out to pi over 4. We can use the pi over 2 and theta equals 0 as kind of our guides. Okay, so there we go. And then we got no man's land from pi over 2 to pi, because that's all negative values of the sine, so we can't take the square root of that. We are increasing by pi over 4, so let's keep going. So if we go to 5 pi over 4, it's going to repeat itself. So sine of 2 times 5 pi over 4 would be the sine of 5 pi over 2, which is the same as sine of pi over 2, so it's going to be 1 times 2 is 2. Okay, and then 5 pi over 4 plus pi over 4 would be 6 pi over 4, which is reduced to 3 pi over 2. And so we'll have a maximum out at 5 pi over 4. Okay. Okay. And if we keep going, we would get to, what would we get to? Plus another pi over 4. It would be 7 pi over 4. And then 2 pi. And then we would start over. And so we would start over back to here, and we would repeat that. So we've got the full graph here. Okay. All right. So that's our graph there. Let's try to convert it into rectangular form. So we have r squared is equal to 4 sine of 2 theta. And we want just regular theta, not 2 theta. So we're going to use that identity we used previously. So r squared is equal to 4, and the sine of 2 theta is going to be 2 sine theta cosine theta. Okay, and then we need r sine and r cosine to convert to y and x respectively. So that's 2r, so we're going to multiply by r squared. So r squared times r squared is r to the 4th. It's equal to 8 r sine of theta and r cosine of theta. Okay, r to the 4th is r squared squared. R squared is x squared plus y squared. And we'll square that, and that's going to be equal to 8 yx. And this one's called, I think it's pronounced lemniscate. Don't hold me to it, but I think something to the effect of lemniscate. That's what this one is. All right, we got one more video, and we'll see you in the next one.